giving us a final answer of 15 a to the 6th power, b to the 4th power. So we summarize this by saying when multiplying terms with like bases, we must add their exponents. And don't forget to label this page 14. Continuing on the back side, we're going to have a new example 1. This is going to be 16 over 8. I asked you guys to expand this out by listing out the prime factors of both numbers. So you guys gave me 2 times 2 times 2, which is 8, times 2 is 16, over 2 times 2 times 2. Now the reason I had asked you guys to expand it is because here you guys can reduce to 1. Several pairs, 2 over 2, 2 over 2, and 2 over 2 all reduced to 1, leaving me with a final answer of 2. So, example 2. Here we have 64 over 8. The easiest part would probably be my 8 factoring down to 2's. And then, of course, 8 times 8 is 64. So I could say 8 times 8 over 8. No, actually, I could have just said that off in the beginning, right? Because now, let's reduce to 1. All I have remaining is 8. All right, and now we have 5 to the 5th power over 5 squared. If I were to expand out again, that would be 1, 2, 3, 4, 5 fives, and 2 below. So let's go ahead and reduce to 1. That leaves me with just 5 cubed. Okay, well, 5 cubed, oh, we actually did that one before. That is 125. We're going to refer back to that 3 in a bit. So example number 4, we have 2a over 2b. Now what you guys had noticed is that what we had done was taken our numbers, that was 1, 2, 3, 4, 5, 6, and then 3, and here there's 1, 2, 3, 4 over 3. It looks like what we were doing was, well, subtracting. So you guys told me my answer would be 2 to the power of a minus b. Well, then I pose this question. What if I had x to the power of b over x to the power of a? I asked, would that matter? And you guys said definitely. Because b is on top, I would say my answer is x to the power of b minus a. It does matter. So since it matters, we went ahead and wrote this note stating that a numerator's exponent is subtracted by the denominator's exponent. That is very specific. So let's move on to example number 5. Example number 5 says 3 cubed times 5 over 3 squared. Okay, so you guys told me here that, well, let's go ahead and expand. And I have 3 times 3 times 3, and a 5, just 1, But then here I have 3 times 3, that's 3 squared. So, well, obviously, these 3's reduce to 1. So I could have actually written this out as 3 to the third power minus 2, then times 5, which of course, 3 minus 2, that's just equal to 3. If you want, I'll even put on here to the first power. So that means our final answer would, of course, be 15. Last example, number 6, I have 2 cubed times 3 squared over 6. And I think this is where you guys are having some difficulty with your assignment. So I'm going to go ahead and factor this out here, or expand it out. So I have, let's see here, I have 2 times 2 times 2, and 3 times 3. But 6, I can also break that down into its factors, and I could change that into 2 times 3. Now, this is really helpful for me because now I can start reducing. So I have 2 over 2 and 3 over 3. Now, if I wanted, I could have broken this down to say, I think I'll write it over here where I have a little bit more room. Just continue over here. That would have been 2 cubed minus 1. So yes, I would have had to factor it. Times 3 squared minus 1 again. And of course, 3 minus 1, that's going to give me 2 squared. And then times 3 to the first power. That would leave me with, well, 4 times 3 is 12. Final answer. So let's go ahead and summarize what we have done. So in all of these, we've been dividing. So when dividing terms with like bases, we must subtract their exponents. Sorry about that. And do know that all we're doing with the actual coefficients is dividing them. All right, we're looking for anything to reduce. Just like on the front side, what we were doing with the coefficients was multiplying them. All right, this should help you out with today's assignment.